Physics NCERT, second chapter, which is unit and measurement, question number 2.22. So in this, we have to define the various part by making some assumption. So in the first part, we are supposed to find out the total mass of rain bearing clouds over the India during the monsoon. So moving to first part. So as we can say that the total over rain over India is equal to total rain over India is approximately can be equal to 10 centimeter, and the area of India can be written as area of India can be approximately written as 3 into 10 to the power 6 kilometer square. And the volume of water, from this we can say that volume is equal to area into height. So from this the volume comes out to be 3 into 10 to the power 11 meter cube. Substituting the value of area and converting h into meter, we can find the volume which is received by the India. So in order to find the mass can be written as density into volume. So mass which is received by India, that is equal to density into volume, and density of water is equal to 1000. The mass comes out to 3 into 10 to the power 11 into 10 to the power 3. So from this the mass received, this is equal to 3 into 10 to the power 14 kg. So approximately this amount of water is received during rainy season. Now second part is we want to that mass, what is the mass of element. So roughly we can assume the elephant which is having, let's say, length of elephant is equal to, on an approximation, 3 meter, height of elephant is equal to 2 meter, and the width of elephant is equal to, that is equal to, and the width of elephant, let's say, that is equal to 1.5 meter. Now as we know that the elephant is used to float in water, so density of elephant would be less than water, so we can approximately assume that density of elephant is equal to 8,800 kg per meter cube. As it is floating in water, so its density would be less than water, and density of water is equal to 1000 kg per meter cube. So roughly we are assuming the density of elephant as 800 kg per meter cube. So from this we can say that the volume of elephant can be written as 3 into 2 into 1.5. So volume of elephant comes out to be, let's say this value comes out to be 9 meter cube. So from this we can find the value of mass of elephant, as that mass is equal to density into volume. So from this implies that the mass of elephant comes out to be density, that is equal to 800, and into volume, that is 9 meter cube. So this is roughly 7200 kg. Moving to third part, which is C, then this we are supposed to find that wind speed during a storm. So we can say that, let's say, the two cities are separated by a distance of, let's say, 200 meter. So in third part, let's say we have two cities which are separated by a distance of 200 kilometer. This is city B and this is city A, and the storm is moving in this direction with a speed V, and it take almost around, in general forecast, the storm takes generally 1.5 hour to reach from A to B. So in order to move from city A to city B, the time taken by the storm is 1.5 hour. So from this we can find the value of the speed of storm, as by using the speed can be written as distance upon time. And the distance taken is equal to 200 kilometer and the time is equal to 1.5 hour. From this the speed comes out to be 400 by 3 kilometer per hour. So this is roughly of order of 100 to 150 kilometer per hour. So this is the roughly the speed of storm is equal to 100 to 150 kilometer per hour. Now the next part, which is we are supposed to find the number of strands on head. So approximately we can assume that the radius of head is equal to 10 centimeter, and the head is approximately act as a hemisphere, and on this hemisphere, on 80% of this hemisphere the hairs are there. So the head is approximately a hemisphere and hairs are present on 80% of it. So the area covered by hair can be written as 80% of total area of hemisphere. So area A in which the hairs are present can be written as 80% of total area of hemisphere, which is equal to 2 pi into r square. So on substituting the value of pi and r, we can say the value of area in which the hairs are present can be given as 5 into 10 to the power 4 square. So the area in which hairs are present, that is equal to 5 into 10 to the power 4 square. So on an average we can say that in the area of 1 square there are average of 7 to 8 strands of hair. So on an average on an area of 1 square, we can assume that 7 to 8 strands of hair are present. 7 to 8 strands of hair are present. So the number of hairs on the area, which is equal to 5 into 10 to the power 8, can be written as, so number of hair on capital A area, that can be written as approximately 5 into 10 to the power 4 into 8, and this roughly comes out to be 2 into 10 to the power 5 strands. So number of strands on the head, that is equal to 2 into 10 to the power 5. So the next part, which is equal to the number of air molecule in classroom. So the number of air molecule in classroom can be calculated as, let us assume the volume of room as given as, so the last part E, this is just an approximation that on roughly the volume of room can be given as that, let us assume the length of room is 4 meter, width is 3 meter and height is also 3 meter. From this we can say that volume of room can be written as 36 meter cube. Now, if we have the volume of room, the number of molecule can be given by gas law. That gas law says that PV is equal to NKT. The temperature of normal room is equal to 27 degrees Celsius, which can be written as 300 Kelvin. So from this, the value of N that comes out to be, where N represent number of molecule. So the number of molecule comes out to be PV upon K into T. So on roughly the atmospheric pressure is equal to 10 to the 1 Pascal, that is equal to 1 atm, that is equal to 10 to the power 5 Newton per meter square, into a volume that is equal to 36 meter cube into K, that is equal to Boltzmann constant, that is given by 1.38 into 10 to the power minus 23, and temperature that is equal to 27 degrees Celsius, or you can say the temperature is equal to 300 Kelvin. On solving this, the number of molecule roughly comes out to be 8 into 10 to the power 29. So the number of molecule finally comes out to be 8 into 10 to the power 28.